Assalamu alaikum warahmatullahi wabarakatuh. This is grade 11 advanced physics, term 2, the academic year 2021-2022. My name is Mr. Adham Issa, and inshallah, this will be like a revision for you to study for your final exams. This revision was based on the end of term exam learning outcomes that was published before on LMS. You can use it to study for your final exams or in general if you want to review anything in your subject. Good. So the first question is multiple choice question 5.2. It's in page 150 in chapter 5, kinetic energy, work and power. So the question states that an 800 Newton box is pushed up an inclined plane that is 4 meter long. So if you take a look at here, once you have something saying like this 800 box, he means this is the weight of the box. Okay, so this is the gravitational force or the weight of the force, or the weight of the box. Usually we write as W. It's really good to underline any information given to you in the question and write above it what does it mean, or what is the physical quantity that it represents. So it's being pushed up an inclined plane. Remember, an inclined plane means that something is not flat, it's not completely horizontal, but it's being pushed upon an inclined plane. Next we will sketch it inshallah. That is 4 meter long. This is very good. This is the distance that the box that will move. It requires 3200 joule of work. So this is the total work needed to move the box from the bottom, from the horizontal plane ground up until the top of the inclined plane. Now I will leave this as is in here, and I will tell you later how can we describe this quantity. So it requires 3200 joule of work to get the box to the top of the plane, which is 2 meter above the base. We will see how this is actually h, or the height. What is the magnitude of the average friction force? Now this is very important to notice that he needs the friction force. He's not asking about the work. In most questions in this chapter, he will be asking you about the kinetic energy, work, and stuff like this. But pay attention here that he only needs the friction force. So I will write F for force and another small f for friction. Okay, assume the box starts at rest and ends at rest. And actually these two are really important. So let's start by sketching. If we take a look at here, as I told you before, it's very important to sketch initially and finally. What happened before the movement, or before the scenario, whatever happened in the question, and what happened eventually at the end. So we need an incline. Okay, this is the ground and this is our incline. Okay, above this incline, look, I will just make it, just get it right. Yep. So if you take a look at here, this incline, we have a box that's being pushed upon the incline. Now this is initially. Finally, what happened? The box reached to this point. Okay, so these are the two states that we have, initially and finally. Now the box is here. Okay, now how can we write these numbers on the sketch that we did? Now we know that the plane is 4 meter long, so the distance from here to here is 4 meters, and the height of this inclined plane is 2 meters above the base. So this is 2 meters on height. Okay, and we know that the weight of the box is 800 Newton. Now it's really good to write that this weight, as we know, is written as W equal to, is the same as the gravitational force, if you remember, which is the mass of the object or the box multiplied by the gravitational field. Now it's given to us in the question to be 800 Newton. Now pay attention that a lot of times he will say that, let's say an 80 kilogram box, so he's giving you the mass, but in different questions he will directly give you the weight, which will take like one less step for you to do. Okay, and you have D, you have everything else. Now what is this number, 3200 joule of work? Now look, we said before that in every question you need first to think, is this a question where there is friction or there isn't friction? Is friction involved in the question? Now it easily shows that there is friction in this question, and our aim actually to find this friction force. Okay, I know that it will be confusing for you, so how can I start friction force and stuff? Let's start easily by discussing objects, okay, or yeah, objects or movement using what? Using friction. Now we know that there will be a difference in mechanical energy, okay? The box was pushed from here to here. Now, initially, if you take a look at here, if we take a look at the gravitational energy, you know that it's zero, UG, let's say initial, and the kinetic energy initially is also zero. Now, why this is zero? Because the box starts at rest. You see, this is really good. Now, let's take a look at here. Now, UG finally is not zero, of course. It's mg, or the weight, multiplied by the height. Correct? Now, what is the height? It's 2 meters above the ground. So you have this very simple equation, mgh, okay, and which is equal to mg 800 multiplied by the height, which is 2 meter. Okay, so now that you know that at this point you will gain some gravitational energy equal to 800 multiplied by 2, sorry, and the answer is 1600 joule. Okay, let me just get it right. Yeah, cool. Now, what is the kinetic energy finally? Now, look, it also ends at rest. This is very important for us. So we know that the kinetic energy finally is equal to also zero, because the final velocity is also zero. Now, what happened in here? Take a look. Now, the box was here. He was pushed all the way to here. Now, without friction, it should only cost us 1600 joule of energy. Okay, because look, you only needed to transfer you only needed for the box to gain some gravitational potential energy, which is UG, okay, but it should be only 1600 joule, but we actually lost 3200 joule of work. Now this makes sense because we have friction. Now this difference in friction, this difference, sorry, in energy, this extra energy that is required by us was lost in friction. Okay, so what is the equation we can write here? We know that delta ME, the difference in the mechanical energy, which is kinetic plus potential energy, okay, plus the work we lost due to friction, WF, is equal to what? Is equal to the number given to us, which is again 3200 joule of energy. Now, what is this? What does this mean? I'm sorry. It means all the types of energy we lost in our motion. Okay. Now, all of these are simply what? 1600 joule. We had nothing initially, nothing in terms of gravity or in terms of kinetic energy, and finally we only have the gravitational potential energy. You can write the whole equation, which is UG final plus KE final minus UG initial minus K initial, and the answer will be, of course, 1600 joule. Okay, so I will change the color in here. Let me make it red again. Okay, good. So this thing is going down to be 1600 plus, we don't know what's the work due to friction. Actually, this is our question in here, equal to 3200 joule, and from this simply you can find that the work due to friction is equal to 3200 minus 600, and the answer, sorry, 1600, and the answer is also 1600 joule of energy. So look, it requires 1600 joule of energy to move the object on top of the ground without friction. Another 1600 joule of energy was required due to friction. But we're still not done. Let's take a look again here. What do you need to find is the friction force. Now, how can we get the force from the work? It's a very simple equation, as you know, that this work due to friction is equal to the friction force multiplied by the distance the object moved. And what is the distance? So the distance the object moved is these 4 meters. Actually, he was here, and along all of this incline he was experiencing this friction force. So this is the distance the object moved, and from here we can say that WF is equal to the friction force multiplied by the distance. So that, what is WF again? 1600 joule equal to the friction force I need to find multiplied by the distance, which is what again? 2 meters. So that we know that the friction force is equal to 1600 over 2, and the answer is 800, of course, in Newton. Okay, so this is it. Okay, this is what we need to find. The answer here was 800 Newton. Let me just write it again, 800 Newton. Okay, and if you go back to the options you have in here, you can simply find that the answer was option E, of course. Okay, so the answer was option B. This is the correct answer. Thank you very much and see you inshallah in next question. Assalamu alaikum wa rahmatullahi wa barakatuh.